Yeah, good afternoon, everyone. Today it's a very beautiful day here in Quebec, in Saint-Hyacinthe, in Jeffo office. And in this afternoon, we are here with the Professor Shah Devendra from the Washington State University to talk about Salmonella. Hey, Shah, it was very nice to have you here. Good afternoon.
Yeah, good morning from here. I'm here in the north part of the America Northwest in Washington State. So for you, good morning from here and good afternoon and good evening, depending on where most our viewers are, in which part of the world our viewers are.
Yeah, this is amazing.
Excited to be here. It was a great visit last summer, I believe, when I visited Jeffo Nutrition. I really hope all of our viewers, wherever our viewers are in the world, that our viewers and their families are staying healthy and doing well in this time of crisis. And I'm really hoping and looking forward to talking about Salmonella, which is way different than what everybody is reading about nowadays, COVID-19.
Yes, but I since I start this conversation, this talking, Shah, one thing that I say is that I cannot talk about COVID because I'm not specialist in COVID, but I have a lot of good specialists in animal nutrition and health, and that this is what we're gonna do. It will help people to have out of mind and different aspects with people and with content that we really know. So I would ask you, I would like to ask you, how do you start with Salmonella? How is your life and your experience with Salmonella everywhere? So tell me.
Well, yeah, it might take a long time, maybe a couple of hours, but I will try to do it in maybe less than a minute here. 25 years now I've been working with Salmonella, and most of my work and experience with Salmonella is in a variety of fields, but mostly focused on poultry and public health. That's what our focus has been. I'm a veterinarian by training and also trained as a veterinary microbiologist. I've been working with Salmonella for 25 years now. We've done a lot of work, and I'll share with you some of the work that we have done as we discuss more about Salmonella and the challenges,
Yes, I know. And I would like to thank you, everybody that is follow us at home and stay safe, of course. And the first question is obvious, but I need to ask. It's like, why it's so challenging for us to control Salmonella in the food chain?
Well, that's really interesting and important question. Right. Yeah, I hear you when you said that you're not expert in COVID-19, and I'm not expert in COVID-19 either, but I'm a microbiologist, so I follow COVID-19 very closely. And before we get to maybe the challenges, why it's so challenging to control Salmonella, which is indeed challenging, because everybody is now reading about COVID-19. I was looking at the data just this morning from John Hopkins' dashboard, which is in real time providing information about how many people are infected and how many deaths. So I saw that there's about 3.7 million people currently, as of today, that were diagnosed with COVID-19. 264,000 people have died. And I put these figures in perspective. So now, if you think about Salmonella, which is very different, Salmonella is a bacteria, COVID-19 is a virus. In 2018, just last year, a study was published by global diarrheal disease researchers. It's a big research team that was funded by Bill and Melinda Gates Foundation. And they really summarized what are some diarrheal diseases that affect people. And what's really remarkable in that study is that Salmonella is among the top 5 causes of diarrheal diseases in people. And if you think about the numbers relative to what's going on with COVID right now, in 2016 alone, Salmonella infected 197 million people versus, if you're thinking about COVID-19, 3.78 million, okay? And deaths, about 84,000 people died of Salmonella in 1 year alone. And that's pretty much the story every year. So that's how important Salmonella is to people. And it's kind of easy to forget about that when we're dealing with something like COVID-19. But it's really, really important. It's one of the top 5 causes of diarrhea. In the US here, about 1.5 million people get Salmonella every year. About 500 people that get Salmonella actually die of Salmonella. So it's a big public health problem. And if you think about that, where is it coming from? Vast majority of the cases are happening because Salmonella comes from primarily food animal sources. So because I have expertise in poultry side and you do also, and you know, if you think about poultry alone, forget about cattle, beef, or you know, pork and other, which are all sources of Salmonella. In 10 years, from 1999 to 2008, 11 years, there were 621 outbreaks reported in the US alone. And third of those outbreaks, 33% of those outbreaks, the major source was poultry and poultry products. So huge impact that our industries have on public health in terms of how Salmonella gets transmitted, what are the sources. So now the question is, we know that it's very important. Has industry done much? There's a lot of effort that industry has put into controlling Salmonella, a lot of effort, billions and billions of dollars of investment, federal and the industry itself, and is still doing to control Salmonella, and yet it continues to cause infection, right? So there has to be something that's very difficult or challenging that we either don't understand or maybe we are not doing certain things in the right direction, why it continues to be a problem. And so when I think about that, really, you know, I think about the biology of Salmonella and why it's so challenging to control Salmonella. So I'll give you a couple of examples. For our viewers, depending on what their backgrounds is, it may be easier to follow. I'm not going to get into too much of the scientific details, but trying to keep it very simple. So if you think about COVID-19, there's about few types of this virus right now circulating. If you think about Salmonella, there is 1,500 plus types that are circulating in our food animal systems. Okay, not all of them are highly prevalent, but many of them are. Hundreds of these types are highly prevalent. The other thing that complicates Salmonella problem is that these Salmonella types, which we refer to as non-typhoidal Salmonella, they tend to infect not just one animal, but they tend to infect multiple different types of animals. So one example is typhimurium, which many of our viewers may have heard of, Salmonella typhimurium. If you think about that only one type, which there are 1,500 different types. Typhimurium infects cattle, sheep, goat, pigs, and chickens equally, and can also infect people. So if you think about that, it's got a pretty broad host range, and all these 1,500 types do have that broader host range. Each one of these types are unique and very different from each other. And that makes it very challenging. So how? Take an example. In our food industry, we use vaccines to control Salmonella, right? And if you think about different types, these vaccines usually contain one or two types, which we often deal with. And if you vaccinate our animals, poultry or cattle with one vaccine that contains one or two types, what you're doing is essentially trying to minimize that one or the second type, but keeping the door open for these other types. And that's why there's these breakouts, you know, always there's one or the other type that's out there causing infection. And I was looking at the data published by CDC over the last 6 to 8 months. There is 3 outbreaks that have been reported. All 3 source is poultry. Each outbreak, and one of them is currently ongoing, is a different Salmonella type. So really that tells us why vaccines have had very limited success, right? And it's a challenge that there are different types. Now, within these different types, there is a huge diversity of Salmonella. So if you think about 1,500 types, each type has hundreds of different strains. And each strain may be unique in some ways. So now we are talking thousands and thousands of different strain types of Salmonella, which makes it extremely challenging at the animal production level and the processing level. So whether you're processing meat or whether you're processing and producing feed for animals, it poses challenge everywhere. So how? I'll give you a couple of examples of what makes it challenging, right? So if you think about meat processing industry, they use chlorine for processing meats, and they use a lot of sanitizers.
US, right? Because in other countries, like for example, Latin America, especially Brazil, for example, this is not allowed. But it's just to position, because we have people from all the world. So in some countries, like in Brazil, we should do all the control pre-harvest. What means before the birds goes to the slaughterhouse, and then we have some control, and of course in the heat treatment or of some meat, you know, when we have a positive. But just to clarify, in US, it's allowed to do some post-harvest that they call control. That means like to take the carcass and use a chloride after that. This is what you are measuring.
So chilling in a chlorinated water. And you're absolutely right. I mean, different countries have different practices. Brazil, for instance, I'm aware, doesn't use chlorine for processing. But I'm just giving you an example of chlorine, just as an example. Other countries may be using other sanitizers, acidic water, alkaline treatments, whatever kinds of treatments that they're using, either pre-harvest or post-harvest. What's important to understand is how this diversity of Salmonella affects those treatments, right? And so I want our viewers to take these as an example to think about the biology and how it might impact not just chlorine treatment, but any other kinds of treatment that they may be using.
Yeah,
Does that make sense?
So you were saying that because we have like this different kind of Salmonella and they have different antigens, and normally they, if you use a vaccine, one vaccine that works for one serotype will not work for another serovar. And you also saying that maybe we are using like a kind of product that works well for one serovar but doesn't work for the other
serovar. Absolutely, absolutely, because of that diversity, right? So most of the products that we use are generally speaking tested on some of the reference strains that are used by the industry that produces these products. So they're going to use either one or two strains of Salmonella. And then as these products get out in the market, they work really well, generally speaking, but doesn't necessarily take into account the diversity of Salmonella. And so what happens in the industry then, pre-harvest or post-harvest, there are types that just don't respond to these products, and they keep coming up, and they keep getting out into the system and keep causing outbreaks. So that's one of the major challenge here. So in one study, for instance, in our lab, and I'm getting a call here, so I'm going to turn this off.
This is alive. This is alive. This is what's gonna happen.
So we did one very simple study in our lab a couple of years ago, and we took 12 different types of Salmonella. And we chose these types because these 12 types are very highly prevalent in the US poultry. And we asked one question, because chlorine is commonly used in the US processing industry as a treatment for carcasses to reduce Salmonella loads. We said, how effective is chlorine in reducing Salmonella if we looked at the diverse types? And we have a model that we use, and so we basically used our model, which is basically a chicken meat model, and we added all these different types to the chicken meat model, and then we added chlorinated water, and then we looked for, okay, how do these types do when we treat with chlorine? And what we found was that only three types. Chlorine was able to kill effectively only a couple of three types, but the remaining 8 or 9 types that are very common in poultry, they all did pretty well. with the highest amount of chlorine that is allowed by the federal agencies here. So the point is, the treatments are being used, and they generally work effectively when you're dealing with types that are very susceptible to chlorine, but they may fail when you're dealing with other types that may be infecting poultry, right? So that was pretty eye-opening, that we have to look at different types and how do they respond. Now, you rightly mentioned that different countries may be using different types of treatments at different levels, either pre-harvest or post-harvest, right? So let's talk about pre-harvest. So how challenging it can be to control Salmonella at pre-harvest level. So Salmonella, different types produce something called as biofilm. So what is biofilm for our viewers that may not be aware? It's basically, you can think of this as a slimy layer. It's a covering that Salmonella can produce around itself that sort of protects Salmonella from a variety of things, disinfectants that you may be using in the poultry houses, for instance, or any sanitizers that you may be using, or acids that you may be using, or antibiotics that you may be using to control Salmonella, or heat treatments that you may use post-harvest to control Salmonella, either on meats or dry foods such as feed and feed products, right? Or raw material that you might be using for producing feeds. And if your objective is to control Salmonella, how might Salmonella not respond to those treatments? Again, it goes back to diversity. If there is Salmonella that produces biofilm, it's going to be your treatments are going to be much less effective.
And do you can mention what kind of reservoir that is more likely to produce biofilm? Because you're saying some kind. So right. What reservoir are implicated to produce the biofilms that maintain them protected against many products, right?
Yeah, and so that's a really interesting question. So I'll give you an example. So we last year we tested more than 250 different strains of Salmonella in our lab. And these strains came from 12 major types, serotypes or serovars of Salmonella that are very common in the US poultry, and I'll name a few. This includes Anaeritidis, which many of our viewers who are working in the poultry industry may be aware of, Typhimurium. If you're not working in poultry industry elsewhere, you may be very well aware of Typhimurium. So these were a few that were included along with that additional ones. All of these serovars that we are testing here are among the top 30 serotypes that cause human disease in the US. So they're very important from public health standpoint. So we took those 250 strains within each of these, total of 12 serovars. And we asked one question, okay, how many of these produce biofilm? And what we found is 80% of our strains, these all came from field samples from poultry. The 80% of our strains produce biofilms. And each serovar produces biofilm, and within each serovar or serotype, there are strains that don't produce biofilm.
So this biofilm, it's an important subject that people sometimes don't talk, but in the practical point of view, this means that, for example, if I have a biofilm, if I don't use like a mechanical way to destroy it, it will be very difficult for a product like a disinfectant or something to go through and to destroy someone else. This is what you mean, right?
Absolutely, especially pre-harvest, even post-harvest in the processing environment. If you're not scrubbing your surfaces, things like that, if there is a strain that has contaminated your environment that produces biofilms, it's going to stay there for long, years, months to years. We know that Salmonella within biofilm can survive up to a year, even in the dry environment. So even if you're not seeing any moisture, any water or fecal matter, if it's completely dry, Salmonella may still be alive there. And so that's what we see that when Salmonella produces biofilm. So what we did is a very interesting experiment which we published last year. And our interest was to see how Salmonella does in a dry environment, right? If it produces biofilm. So we took about 3 biofilm producing strains and couple 3 of the biofilm non-producing strains. And these were all from Salmonella enteritidis type, which is very common in poultry. And what we did is we, in collaboration with food engineering scientists here at WSU, Dr. Juming Tang, we took these strains to his lab, and his lab works with dry food products, including wheat flours, things like that, which may apply to the feed industry also, as feeds are usually processed with high temperature treatments. So we were interested in seeing how does biofilm protect Salmonella to heat treatment. And so we basically, what we did is a very simple experiment. We took these 6 strains, 3 biofilm producing, 3 biofilm non-producer strains, and we added them to wheat flour. And then we took the wheat flour to our biological systems engineering lab, and they treated these wheat flours to a variety of treatments at different temperatures. So 80 degrees was the highest temperature. And what we found is that when you treat at 80 degrees Celsius for up to 20-25 minutes, when the Salmonella that doesn't produce biofilm, 90% of this Salmonella dies within 20 minutes, actually within 6 minutes.
Okay.
And when you have Salmonella that produces biofilm, it takes more than 14 minutes, sometimes up to 20 minutes to 25 minutes to kill 90% of the Salmonella, not all, only 90% of the Salmonella.
Wow,
so
25 minutes.
There you go. So the question for the industry folks would be, how practical is it for them to treat feed ingredients or feed products for 25 minutes at that high temperature? I mean, how might that affect your protein quality and things like that? So think about how hard it is to kill Salmonella when it produces biofilm. So this is, this poses significant challenges to pre-harvest, post-harvest, feed production at all levels.
Well, this is interesting because, many of people that are follow us today, they some of them working in the poultry or animal industry, and they work in the nutrition. So this means that in the feed mill, what you were saying, that in the feed mill, if you have, for example, the contamination of Salmonella, and I have been working field for a while, because I don't want to say how long, but when I used to visit feed mill, and I did it a lot, because in my university, we have, at the beginning of my career, I have a program that we call critical points of control of mycotoxins in feed mill. And you start with mycotoxins, but later on you go to Salmonella as well. So we went to the feed mill and tried to find where is the critical points where you have moisture or conditions for development of fungi and Salmonella. And when I observed that, once we have some troubles with Salmonella in one of my company that I used to be consultant, and in that company, what we saw is that Salmonella, the specific Salmonella, was present in almost everywhere. Because people always have the idea that Salmonella is always in the meat products or products that are coming from the animal. But from this experience and another ones that I had after it, I observed that there is many different, like I saw Salmonella even in minerals that are using soybean, like you say, wheat, corn. So there's different kind of ingredients that have Salmonella. So what you're saying to me is that if I have a strain that produce biofilm, I really will have a big issue to destroy the Salmonella. Like you're saying that I need to heat it 8 degrees for 25 minutes to destroy it. That what is impossible when you think about these conditions. But do you think that Paletine, are you familiar, like Paletine conditions that increase? Do you think that Paletine is a way that we can control Salmonella, even this one? Have you worked in that?
So I'm not sure if you will take this as a bad news, but here is something that we have learned from at least in the last few years while working with the dry foods and feeds. Number one lesson that we have learned is you're right that most people believe that Salmonella likes moisture and that moist foods and meats and meat products, which is where more Salmonella is there. But really, what we have learned here is when we keep Salmonella in a moist environment and when we treat Salmonella with high temperatures, it gets killed fairly easily. Very, very easy to kill in the moist environment, especially with the heat treatment. When we put Salmonella in a dry environment, for example, wheat flour, when you throw Salmonella in wheat flour, there is very little or almost no moisture there. So once it gets dried, for some reason, whatever that reason is, which we don't totally understand, biofilm could be one, but even without biofilm, Salmonella becomes pretty darn resistant to heat killing. Very, very resistant. So pelleting, your question was about pelleting, right? I'm familiar with pelleting, and I know there's, I'm not sure exactly what the temperature are, but they're higher during pelleting. And you might think that those high temperatures might be able to kill Salmonella, but given the fact that as you're pelleting in a dry, very dry environment, and if Salmonella is already there, contaminated maybe your ingredients, or at any step, if your equipment is contaminated already with a biofilm producing Salmonella, and if that now is contaminating ingredients or the pellets, I would say if you're thinking about pelleting being effective or the temperature being effective at that point, maybe you'll be surprised at how well Salmonella might survive there. And so I think the key is, especially in the feed industry, if you're thinking about controlling Salmonella, the key is to control prior to pelleting, and then use pelleting and high temperature as an additional measure to control. And the additional key will be to make sure that the equipment, the processing lines, are free of Salmonella. And the ingredients, I think it might work better if the ingredients are treated in some way prior to mixing.
So you are saying that really the Salmonella, when you think about the feed, especially in feed meal, we need to really rethink the way we are controlling today. Like I know that many companies around the world, they have a lot of big work inside. Like in some countries, they put like high temperature as a measure to reduce Salmonella. But as you're saying, maybe you need to looking for the strain of Salmonella and the sensitivity of it to really be sure that we are using, because there is not one treatment that is effective for all kind of Salmonella, even in these conditions. This is very interesting.
Yes, absolutely right. And the other thing to think about is, as an industry, you cannot stop looking for strains, because there are a variety of strains that come into the production areas from outside. And each strain can be very different. So you may have a strain at one point that you're able to control at certain temperatures, but that process may sometimes fail partially or totally with another strain, because each strain can have a very different level of resistance to high temperatures or resistance to disinfectants, depending on what strain that is, how much biofilm it is producing. What we see is if you have multiple strains that all produce biofilm, but one strain somehow takes maybe 20 minutes to be killed at higher temperatures, but the other strain that also produces biofilm is killed in 14 minutes. And the third strain might get killed in 12 minutes. Yeah. So even I think we have to be, as an industry, has to keep in mind to keep track of what's happening, what's coming in, and how these strains are responding to the treatments, and be ready to maybe change continuously or periodically the processes and process temperatures, which may be very hard and impractical in some places.
Unfortunately, because of the time, we cannot go so much in the details, but I'm sure that you are doing more research and you have papers around this area. And I think that there is a lot of things to do. But another subject that I want to talk to you that I think that is very excited, and here Jean Fontaine, the owner of the company, he always talk about the idea that with nutrition, we are able to starving the microorganisms. Like we can, he has these ideas. And I start to read your papers, and I'm very excited and want you to talk with all the people that are following us today about your ideas and your research in terms of the nutrients requirements of Salmonella. And how do you think that nutrition, I'm saying nutrition in the way like amino acids, vitamins, in some way, we are increasing the possibility to have Salmonella?
Yes, that's really fascinating to me. That's a fascinating subject to me. And as we discussed when I visited your company last year, in the last 5 or 6 years, I've taken all we have done in the last 20 plus years, learning from the diversity of Salmonella and how different strains. So we've done a lot of population studies on Salmonella, and we've learned a lot about how Salmonella responds to heat or may survive against disinfectants, different strains, things like that. And what we have learned is, while studying the diversity, is that most of the current interventions fail at some point because the Salmonella strains are able to survive one or the. Sorry, yeah, I should have muted my cell phone, but I haven't, so I'm going to. But so this is really interesting. So what we are doing in our lab here is we are trying to understand the nutritional needs of Salmonella. So remember, I in the beginning I told you that there are a variety of strains, and they can infect, each strain or each type can infect different animal hosts. And so if you think about that. Researchers that work with Salmonella, I've come across two types of researchers. One that think of Salmonella as generalist. So most people who work with Salmonella and they think of this as generalist think that irrespective of the type, each type is very similar and may have very similar nutritional needs. And that's the reason they can jump from cow to chicken to maybe pigs, or, from chicken to people and whatnot. And that's one way of thinking, right? Because they're all Salmonella. So there has to be something common among them that makes them Salmonella, and they can be generalist. And I've met with other group of people that think of Salmonella as specialist. And I'm more on that side of the group where I think Salmonella being a specialist. And what I mean by being specialist is, you can be versatile, but there is a limit to how much versatile you can be. If you're jumping from chicken to people, you have to have certain arsenal or weapons that you have to be able to use to adapt in these two totally different hosts. Chickens are way different than cattle. We manage chicken differently than cattle. We feed chickens differently than cattle. So the chicken's intestines are going to be very different than cattle intestine. And in order for Salmonella to adapt into these two different hosts or into human intestine, it has to adapt. It has to change certain ways how it can. So if you think about that, then you can think about nutritional needs. Why nutritional needs? One reason being Salmonella can cause disease in people. But if you think about chickens, cattle, for the most part, it does nothing to these animals. It just hangs out, right? And in order to hang out in the intestine of these animals in large numbers, it needs to be able to eat something. It needs to be able to survive. And so it cannot just eat whatever comes through the feed, because when chickens are eating feed, they're using all those nutrients for growing. So the primary nutrients that are present in the feed has to be utilized by normal beneficial bacteria that chicken intestine has for digestion, for weight gain. And so if you think of Salmonella now, which is hanging out in that intestine, it has to then compete with these normal beneficial bacteria, something like probiotics that we often use, right? They're competing with Salmonella. So what is Salmonella going to do in that environment, in that highly competitive environment where there's billions of bacteria against which it has to compete? And so what we think Salmonella does, and I'll give you examples of with data as to why we think what we think that Salmonella is doing, is it's sort of stealing nutrients. And it's not stealing primary nutrients. So for instance, tyrosine is one example of amino acid, right? It's a semi-essential amino acid. It's present in the feed in very high numbers or high amount. But if you look at Salmonella, none of the Salmonellas can use tyrosine as a nutrient. So who is using tyrosine? Mostly beneficial bacteria is using tyrosine. They're breaking down tyrosine. They're helping chickens to utilize tyrosine as a source of energy, right? And Salmonella just can't use tyrosine. So what can Salmonella do then? It has to rely on some other nutrients. So what we have learned in the last few years is we have done some experiments in our lab to understand and address a couple of questions. Is Salmonella a specialist? Can it use different nutrients in different hosts? And if it is a specialist, what are some nutrients that Salmonella is using? And ultimately, if we understand that, how can we then starve Salmonella of those nutrients? If we know what nutrients Salmonella is using, maybe we can devise, maybe your feed industry can come up with some ways, which I think Jeffo has quite a good technology of releasing nutrients at different parts of the intestine, releasing nutrients in feed at different times, and things like that, which are pretty innovative. And maybe something like that can be used to control Salmonella. So I'll give you an example of what we have learned, if we have time, and if we can continue our discussion, because this is pretty interesting.
Yeah, let's go.
Okay, so what we've done in the last few years, we have taken one of the very common types of Salmonella, Eritidis, which affects poultry and people in our lab. And what we have done is we have genetically manipulated this particular type. We have taken out many genes of this type to find which genes Salmonella is using to acquire nutrients in these hosts. And then we have gone to animals such as chickens and mice to understand how these genes help Salmonella to acquire nutrients. And what we have learned is that there is a bunch of genes that Salmonella uses to acquire nutrients in the mouse intestine. But it appears that those genes are not necessary when Salmonella is hanging out in chicken intestine. So what are those nutrients then that Salmonella is using for which it requires these genes? And we have identified at least two nutrients. And the names of those nutrients are tyramine and D-glucuronic acid. So what are these nutrients? They are basically found in the intestine. To our surprise, what we learned is that these nutrients are byproducts of microbial metabolism in the intestine. So what are these beneficial bacteria doing in the intestine? They're basically digesting food. And when they're digesting food, just like animals, when they digest food, they're going to spit something out.
Yes.
Which is feces, right?
Yes.
So for bacteria, there is also feces that they spit out. And so that feces is basically these nutrients that are not useful to people or animals, but Salmonella can use those nutrients, tyramine, D-glucuronic acid, which are a byproduct of the beneficial bacteria. So it's pretty clever. It's stealing those nutrients, right? So we learned that, and we said, wow, maybe someone using these nutrients in mouse intestine to cause disease. So then what we said is, well, can we then design a strategy such that we can starve Salmonella of these two nutrients. So we looked into Salmonella metabolism and we found all the metabolic pathways of Salmonella. And then we were lucky that we were able to find drugs that can actually inhibit those pathways. And so in our lab, again, we did some experiments, and this data is not published yet, will be published hopefully in the next couple of months. But the good news is that in the test tube, we can show that we can completely inhibit Salmonella growth with these two drugs that we now have. Salmonella is just unable to utilize these metabolites. So what we think we can do now, or at least what we can try and do now in the animal system, is we can go back to the animal and try and use these drugs and see if we can control Salmonella in the intestine by using these drugs, by specifically inhibiting Salmonella's ability to utilize these nutrients. So in other words, what you just mentioned, Elizabeth, is starving Salmonella of these nutrients. Now, this may not lead to elimination of Salmonella, but what we are shooting for is, can we reduce Salmonella by, substantial numbers, maybe couple, 3 logs? If we can, then there are a lot of other interventions already industry has in place.
So in this aspect, do you think that also, for example, you talk about the amino acid tyrosine? I'm wondering if there is a kind of amino acids or specific nutrients from the diet that maybe you can regulate, and this way you stop the growing of Salmonella?
We haven't identified specific amino acids yet, but I want to go back to the example of tyrosine. And you can think of methionine, for example, right, which is used by poultry industry a lot.
Methionine is a good example, for sure.
Right. So what I gave an example of tyrosine because tyramine, which is used by Salmonella, is a byproduct of tyrosine metabolism. Mm-hmm. So when tyrosine through feed gets into the intestine, it will be attacked by bacteria, normal bacteria, the probiotic bacteria, or the beneficial bacteria. They'll attack tyrosine, they'll produce energy, which is used by hosts. And then they'll spit out tyramine, which is basically a byproduct. And Salmonella is going to basically use tyramine. So the point would be, if we can inhibit tyramine acquisition, that would be one way. The other way, if we were able to find, and that's why I said we need to understand what Salmonella needs in the chicken intestine, what Salmonella needs in the cattle intestine, what it needs in a pig intestine, and if it needs different metabolites, different nutrients, then you can start thinking about how can we regulate or change feed formulations such that those nutrients become available less and less. Maybe you can encapsulate some of these ingredients. Maybe you can make sure that these ingredients that are needed by Salmonella are released at certain points where Salmonella is unable to acquire them, right? Whichever that, method be, once we know the nutrients, I think the technology, for instance, used by Jeffo may have a great potential there, that if we can regulate that, maybe we can in some way paralyze Salmonella or starve Salmonella from getting hold of that intestine and increasing in numbers that it does.
Yes, it's interesting. In fact, all what you are talking is very innovative, and this is why we are in the innovative of R&D of Jeffo. And we want to talk more about that. Basically today with our technology, we are able to deliver a specific essential oils and organic acid in the way that they are protected from the stomach, and this way they reach the sickle and the end of the gut that they need where Salmonella is. So really, I think that this could be addressed. Today we have already as alternative, but in the future we can have even another alternative with nutrients. And this is very interesting. But when we are starting to talk about this interesting subject, the time flies. So we are already at the end. And I would like to thank you so much for your time here. But before we finish, I would like also to ask you, what's your message for people that are followers in terms of control of Salmonella? From now, the technologies that you have now, what's your final message that we can take from?
I think there's maybe a couple, three things to keep in mind. Those who are interested in Salmonella and trying to control Salmonella, whether you're working in industry or academia, we need to change our approach to the issue of controlling Salmonella in a substantial way, at both animal system, at a live animal, and the environmental level, right? So, you know, we need to be thinking about our Salmonella problem sort of from, out of the box thinking is what is needed. We need to move towards strategies that work independent of the type. So most of the current strategies are designed or the focus has been to control one or the other type. So for instance, poultry industry, we're mostly focused on Enteritidis. And then every once in a while, if another type comes up, then the whole focus goes towards controlling that type. And then that type is controlled, but another type comes up. So Heidelberg is an example, right? We have controlled Enteritidis largely, yes. But then a decade ago, Heidelberg came up. And then I can almost guarantee that a couple of years, 5 years, another type will come up, right? So our strategies have to be designed in ways that they work independent of the serotype. And in order to develop those strategies, I think people need to, anytime they're devising strategies, they need to be testing not just one or the two types of Salmonella, but multiple types and multiple strains within those types. So I think for those who are developing strategies, it's very important to think out of the box and not test their interventions just on one type and say, hey, this works, because it may very well fail right away. Right? So test on multiple types. The other thing I will say is we need to think about implementing some innovative ways. For instance, the example that I gave you, we have the drugs that can inhibit Salmonella's metabolic pathways, right? We think, we believe that we can use those drugs, at least at the experimental level right now, to see if that works in the animal system. But our challenge is, how do we deliver these drugs? How do we make sure that these drugs are released in the intestine where Salmonella is, right? And that's where I think people who are working in, let's say, feed industry, or if you're working in the industry where you're looking at delivery of antibiotics or delivery of drugs, and if you have technologies that can solve these problems, that can help us figure out how effectively we can make sure that these drugs or any other molecules that we are able to develop can get to the sites where we want them to work. For instance, can we put these drugs in your pelleted feed such that they're protected from degradation and get to a certain level in the intestine and are released there, and then effectively control Salmonella, right? So I think we need to work towards those type of technologies where we can effectively deliver interventions and try and control Salmonella. So I think those will be the few messages that I'll provide to our viewers.
Very good. Thank you so much for your time. And I take it as a final message that the delivery of what you have for control Salmonella is very important. Thank you for your time. Have a good day.
And appreciate everybody's time.
And thank you to everybody at home. Next week we will be together with Professor Juan Rodriguez he will talk about immunity. And we talk in Spanish, so I hope that all the Spanish people can follow up us in the next week. Thank you so much and see you soon. Bye-bye.
Gracias.
Gracias.